In this video, we're going to take a look at combining three things. We're going to create an average location for the survey. We're going to assign that to the survey's project location. And then we're going to convert these grid coordinates to ground, scaled about that project location for stakeout. So this is a BLM survey. We're working in PLSS, so we've got geodetic coordinates, true bearing, and geodetic ground distance. So let's get started. I'm going to open up the survey information, put that right up here where we can see it. And I'm concerned about this location information right here. I want to create this. So I'm going to come into the drawing, and I'm going to window just the parts of the drawing that I want. So I don't want this west quarter corner over here. I just want these points here where I'm actually working on the survey. I'm going to right click to end that. Then I'm going to choose COGO, average point. And I'm going to refresh this, and I want the 13 selected survey points from the drawing. I'm going to compute that. I'm going to plot that. And you can see that, yeah, this is about where I expected that average to be. I'm good with that. And then I want to update the project location. Okay. When I update the project location and say yes, Traverse PC takes that average point information and it now becomes my average project location. Now, that's important for a couple of reasons. It's this elevation that I'm going to use here to tell Traverse PC. I want to make sure that gets updated properly. Here we go. We're going to compute geodetic distance at the project elevation of 2,467 feet. Okay. The other thing I did when I clicked this button up here is I said, take this elevation factor based on the elevation and this grid factor based on its location in the coordinate reference system, and I'm using NAD 83 Oregon South, okay, and multiply those to come up with this combined factor. So now I've computed this average point, I've used it as my project location, and I can tell Traverse PC, okay, now I've got these corner moves over here that I want to stake out. The problem is that the coordinates for these are grid coordinates. So if I have a data collector that doesn't understand scaling and grid to ground, that sort of thing, and I want to go out there with a total station and stake out these corners, I don't want to necessarily send out grid coordinates, I want to send out ground coordinates. And I'm just going to show you the easiest way to do that. I go to File, Export, and let's just set this up. I want to export that traverse as ASCII, and I'm going to tell Traverse PC I want to convert the coordinates based on, okay, and look what I've done. Here's my use project location, so it brought in that location I computed from the average. As soon as I selected ground, Traverse PC brought in that combined factor, but it brought it in as an inverse. So combined factor goes from ground to grid. The inverse of that goes from grid to ground. Some people call that a project scale factor, or ground scale factor is what you'll hear it sometimes called. But Traverse PC just tells you that's 1 over the combined factor. And I can choose OK now, and Traverse PC says that's the factor I'm going to use when I export these coordinates. And I'm going to scale them about that average point. So let's go ahead and export this. And I'm going to call this ground corner moves, just so we have a name for that. And let's go ahead and export that. Let's preview that to see what we actually got out of it. And I've got that over here on another monitor, so let me just bring that over. So here now are the coordinates that I would send out to my data collector. And when the data collector stakes out point 540, 420, these are GCDB point labels, by the way, from point 93, these coordinates are going to produce this 65.16 ground distance. Okay, so they are going to accommodate or compensate for the fact that I'm not staking out these grid coordinates, I'm staking out these ground coordinates, and these are the coordinates that my data collector has to stake out the correct distances at the ground. So real easy to take this average point that I computed, to use it as my project location, and then to use that project location and the combined factor at that location to scale points on the grid up to ground for stakeout.